All right, let's talk about direct variation problems. Let's talk about splitting something up. No one buys CDs anymore, but let's put that down. No one buys DVDs either, so I'll just say DVDs. Except for people like me, who buys DVDs and does Netflix, and I'm stupid. But anyway. Sometimes
Can't you buy like the movies from Netflix? No.
You can
just have to
download
do
them.
monthly.
All right.
You
So
just don't turn it in.
I download everything from Netflix. I don't ever have a hard copy of it. Yeah. So if you bought one DVD and it cost you $15, just assume that the price was steady. If you bought two of the same one, then it would be $30. If you bought three, it would be $45. If you bought four, it would be $60, and so on, right? If they were the same one. But basically, you could set that up with direct variation, that price divided by the number you bought would tell you K, and K would stand for the number,
The original cost?
the original cost. So if you spent $60 and you divided that by 4, originally they cost but $15 each, right? So you would find the original cost. Or you could write it out this way. Price equals 15 times the number. So 15 times 4 would tell you 60. Okay? So you could write these problems two different ways. Which takes us to page 471 with the first example. The first example says, the amount Ellen charges for banquet food varies directly as the number of people that attend. If Ellen charges $780 for 60 people, how much does she charge for 100 people? Well, what is that relationship? Well, K, we want to know how much she charges per person. So K equals charge divided by the number. Well, we're told that she charges $780 for 60. So K equals 780 divided by 60. So what is that going to end up being? What is 780 divided by 60? How many times does 6 go into 78? 13. Okay, so the answer is 13. So she charges $13 per K, $13 per head. Well, now, if there's 100 people there, how much is that going to cost? Well, $13, you can do this in your head, times 100 equals the total cost, which is K again, which is 1,300. Okay, so we can easily figure that out by setting up these direct variation problems. If you're driving at a constant speed, so that's the big clue, constant, doesn't change. The distance Maggie travels varies directly with the amount of time she drives. If Maggie drives 75 miles in 1.5 hours, how long does it take her to drive 100 miles? Well, K equals distance divided by time. K equals distance divided by time. That's the first half of the problem. We want to know what that speed is. And we were first told that she drives 75 miles in 1.5 hours. So that's K equals 75 miles in 1.5 hours. What is that answer? 50 without looking at your book. Cheater. Her constant speed is 50 miles an hour. Now, we want to know how long does it take her to drive 100 miles? So now we have distance. We know her distance is 100. We know her speed is 50 miles an hour. We don't know their time. Although we should be easily able to figure that out. I wrote H, I should have written T. So what is 100, like an equation, let's divide by 50 on both sides. What is 100 divided by 50?
2.
So her time is 2 hours. Her time is 2 hours. Try one more. There were 23 people in line in front of Delia waiting to be helped. 3 minutes later, there were 18 people waiting in front of Delia. Predict how much longer Delia will wait to be helped. All right, so we were told 23 people in line waiting to be helped. 3 minutes later, there were 18 people. So in that 3-minute time span, how many people got helped? No. What's the difference between 23 and 18? So 5 people got helped in 3 minutes. Okay, so that's a long line. How much time is that per person? What is 3 divided by 5? Bless you.
1.5.
No. Look at it. Set it up.
Oh, 6.6.
0.6.
So
0.6 minutes per person. Okay, 6
not
tenths of
very-
a minute per person.
So like 15 seconds.
Okay, so it's not a lot of time. Now, we don't know with any certainty that the next 18 people are going to go at that same rate, but we're going to assume they are. How long do you have to wait then for the rest of the time? Well, what's going to be your wait time? W equals 0.6 times, well, how many people do you have left?
18.
18. What's your wait time?
108 seconds.
Don't be about your decimal.
Oh, 10.8.
10.8, is that seconds or minutes?
Minutes.
It's going to be minutes. So your wait time would be approximately 11 minutes to round it. Okay, it's 0.6 minutes, so you have to change it. So you got 11 minutes per, is going to be your wait time. So when you set up these problems, you're going to start off with the division problem. We're going to do another one. And then you're going to end up with a multiplication problem. So let's try A on page 473. The distance a coiled spring stretches varies directly with the amount of weight hanging on the spring. If the spring stretches 2 centimeters when a 30-gram weight is hung from it, how far will it stretch when a 75-gram weight is hung from it? So we got K. So always start with K. K equals distance divided by weight. So distance divided by weight, because that's the information we were told. It's a ratio. I don't have to change the way it's set up. I just set it up. That's K equals 2 centimeters divided by 30 grams. Well, what is 2 divided by 30?
15.
I don't think it's 15. Use your decimals. Is it 0.6?
Yeah.
Point zero
Repeating, so.
Or
0.06?
Yeah.
Okay,
Yeah.
it's repeating.
if you keep both zeros, but
Oh, yeah.
Okay? You gotta use your decimal. Okay? Now, as we set this problem up, now we gotta set it up for a 75-gram weight. Okay? So the 75-gram weight, we wanna know how far that'll stretch. So what is 75 grams times 0.06 equal?
4.5.
4.5 centimeters. Okay? So the distance is 4.5 centimeters. Okay? Yes, this is repeating. I could have rounded it up to 0.07. I would have gotten 5. Okay? Any questions? So you set up with the division, then the multiplication. So B says the number of words Tom types varies directly with the amount of time he spends typing. So words to time, right? K equals words to time. He types 100 words in 2.5 minutes. 100 divided by 2.5, what is that? So 1,000 divided by 25, what do you get?
1.
Okay, 40?
And then you do 40.
That's 40 words a minute, right? 40 words a minute. How many words did he type in 15 minutes? So 15 times 40 is
600.
600 words in 15 minutes. Okay?
Seems legit.
It is legit. It's slow, actually. All right? There you go. So you set up with the division, you end up with the multiplication.